Hi everyone, in today's video we're going to have a look at joining methods for materials. So specifically what we're going to look at today is joining methods for metals and then for timbers as well. So we'll go with metals first of all. So you've got MIG welding, which stands for metal inert gas. So what happens is you've got your welding torch and then you've got a consumable rod that is on the inside of the torch, so it's fed through the torch from the actual box next to it. Then what happens is that is an electrode that, along with the gas, creates an arc that makes the flame. That is how you make your weld. Okay, so it's important to remember the key thing here is that your electrode, the wire, is fed through the actual welding torch. The next one, TIG, is the key difference here. So we said with MIG you have the electrode was fed from within the torch. Here you actually have a separate filler rod that's used instead. So you are holding the torch in one hand and the filler rod in the other hand, and you are combining the two while applying your flame to get the weld as well. So because there's like two hands to do it, it is a lot more challenging to do. It does require a much higher level of skill, but typically it's used for stainless steel, non-ferrous metals, and is a little bit more difficult. So oxy-acetylene welding, this typically isn't really used much anymore because it's considered a little bit dangerous. So it is used to weld low carbon steel, sheets, tubes, plates, that sort of thing. But it's become obsolete since MIG and TIG welding have become more popular. So the reason why it's considered dangerous is you've got your two separate gases. So you've got oxygen in a cylinder, and then you've got acetylene in a cylinder. So obviously, if they were to be pierced, it would explode. But the benefit of it, and why it's still used a little bit, particularly in countries where you're sort of out in remote locations, is you don't need electricity. So if you imagine like in America, where you might find garages that are in the middle of the desert, or if you're in a country where you are quite far away from the nearest repair shop, where it may be, oxyacetylene welding is still used because it doesn't require electricity. So you've got your two gas canisters and you release those through, and they both feed through a hose pipe into your torch, and then that is where they join together to make your flame, to make your weld. Next is brazing. So this is probably the most common one you may have used at primary school, at secondary school, sorry. So you've got your blowtorch, and then you've got brazing rod. So what will happen is you have got your material, you have to clean it before, you then put something called flux on it, and what flux does is it stops it from oxidizing, it stops it from rusting, and then you apply heat to where you want it to join, and then you get your brazing rod and you hold that over and it melts the brazing rod, and then it goes into the join. Now, it's also known as hard soldering. It's sort of like a bigger version of doing like normal like electrical soldering. It's becoming quite outdated. It does still have its place a little bit, but it's becoming more and more rare that it's used commonly. So next is soldering. So I imagine most people have done this at some form in secondary school. If you've ever done anything electronics wise, anything with circuit boards. So you've got your soldering iron, which gets about 375 degrees, roughly, depending on what brand of soldering iron you're using. So you have then got your solder, which is on a separate reel, and on your circuit board. Now your circuit board essentially is copper, and then you scratch away where you don't want copper, because obviously electricity goes through copper very easily. It's a very good conductor. So you have copper board, and then you etch away where you don't want it to go, and then you put your components through, and then you'll just solder. So typically what we do, you get your soldering iron, make sure it's clean, put a bit of solder on it, let the heat transfer. It takes about 10 seconds, hold it onto where you want to solder the objects, and then apply some more solder to it, remove it, and it's done that way. It's typically used in electronics. It is also used a little bit in sometimes some kinds of jewelry as well. So other joining methods for metals, you've got riveting and pot riveting. You've then got self-tapping screws, machine screws, and nuts and bolts. So now we're going to talk about timbers. So obviously there are things like nuts, bolts, screws, and joints. I'm going to get you to have a look at those yourself because there's quite a few of those, but I'm going to go over what is called knockdown fittings. So these are ones where you may, if you put any IKEA furniture together, you may have seen them. So if we start at the top, so you've got a batten, where if you have your two bits of material together, you would put a batten of material, and then you would screw into each side that way. You have got cam locks, which are very common in IKEA furniture. So there will be a locking screw in one piece and the screw in the other. You put it together, and then what will happen, as you see in the animation, you put a screwdriver in and tighten up, and it'll hold it together. If you ever put a desk together, from IKEA, they're very, very common for putting like legs and then drawers on um, flat pack furniture. So plastic corner blocks. So these are similar to battens, but a little bit smaller depending on what sort of area or size you are trying to do. You then got two block fittings. So this is again similar to battens, but instead you've got two. So you have one batten fitted in place already, and then you have another batten which have another screw to it. So you're actually screwing the extra piece into the other batten. So it's never actually properly fit to the bottom piece. And then you've got your rigid joint, which lets you do corners without doing joints. So you'll have these little plastic parts that allow you to screw in sideways and upwards as well. So those are the most common knockdown fittings. What I want you to do is, can you then go on page 72 to 77, pause the video, and then can you have a look at the other temporary and permanent joints you can find, specifically looking at different kinds of wood joints. So pause the video, have a go at doing that, and then we'll put questions on as well. Okay, so we have got a few questions there. What I want to do again, I'm going to pause the video, give yourself about 15 minutes to answer those questions, and then we'll come back as well. Okay, so the key difference between TIG and MIG welding is the electrode in MIG welding melts into the joint, whereas TIG, a filler rod is applied, so you actually have to hold a separate rod. What are MIG and TIG used for? Frames, piping, car parts, those sort of things. What is oxy-acetylene welding and why is it becoming obsolete? So it's a joining method that uses two high pressure gases, so your oxygen and your acetylene, mix into a flame to form a weld. Why is it obsolete? It can be more dangerous, it's less consistent, and now MIG and TIG have come into place as well. Explain the brazing process. The material is cleaned and prepped, then covered in flux. Heat is then applied, and then once it gets to the right temperature, brazing rod joins the flame, and then it melts down to where you want to go. What is soldering mostly used for? Joining precious metals and electronic circuits. What is pop riveting and why is it replaced riveting by hand? Permanent joining method where a rivet is placed in a hole and squashed. So pop rivet, now you have what's called like a rivet gun, which you may have seen. So you have a little rivet, you'll put it into the rivet gun, you'll drill a hole into the sheet metal you're trying to join, and you'll squeeze it, and essentially it's almost like a stapler for metal. Because what you used to have is you had riveting, you'd have the rivet, and then you'd have to hit the rivet with a hammer, and now a pop rivet just means it's a lot easier, a lot more consistent. Then 3 temporary joining methods and the benefits. Self-tapping screws, machine screws, nuts and bolts. But what you can't just say is like screws and things like that, because there are different kinds. So self-tapping basically are the ones that got a sharp point on them, and you don't necessarily need to drill it like a pilot hole to go through them as well. So that is joining methods. If you've got any questions, if you send me a message on Teams or by email, and I'll get back to you.